All right, we're getting to the end of chapter 9 here, where this is the last section, and we're going to do systems of linear and quadratics. And what a system of equations is when you graph two lines on one graph and they work together. One represents one situation, and another represents another. And you can get different pieces of information by where they cross or if they don't cross at all. So example 1, they want us to solve this system of equations by graphing. And I show you up here that where your two equations cross is your solution to the system. In this case, I have two solutions because it crosses in two spots. In this case, I have one solution because the quadratic just barely touches the line. And in this case, I have no solutions because they don't touch each other at all. So for example 1, we want to graph the two equations. So first, I'm going to graph the line because the line is easiest to graph. So the slope of the line is -1 and the y-intercept is 2. So we're going to go up 2 on the y-axis and put a point, and then our slope is -1, so we're going to go down 1, right 1, down 1, right 1, down 1, right 1. And then I have a line that goes through those points, and I've graphed my line. So now I need to graph my quadratic. Probably the easiest way to graph the quadratic is using the vertex formula. So it's going to be -b over 2a. That's going to be +1 over 2 times 1. So it's 1/2. That's my x. And to find my y, you plug 1/2 in for x and you'll figure out what y is. So it's going to be 1/2 squared minus 1/2 minus 2. So 1/2 squared is going to be 1/4 minus 1/2 minus 2. And that's going to be, if you go ahead and put that in your calculator, you do your operation, you get -2 and 1/4. So my vertex is going to be 1/2 and then -2 and 1/4, which is not ideal, but it is what they gave us, so we have to graph it. So we're going to go 1/2 halfway between 0 and 1, so it's going to be right here, and we're going to go down 2 and then down 1/4. So it's going to be about in here somewhere. Then my y-intercept is always c, so my y-intercept is going to be -2. And then I can mirror that on the other side, and I have this little graph. I can find my x-intercept. I don't want to go ahead and draw my curve because I don't know exactly where I need to draw it, even though I do have my 3 points. So I'm going to go ahead and find my x-intercept. And the way you find your x-intercepts is you solve it. So we're going to replace the y with 0. I'm actually just going to take this and I'm going to move it up so I can see what I'm doing. Alright, so we take our y and we replace it with 0, and then we take our equation and we're going to try to solve it, and that's going to tell me my x-intercepts. So that's going to be x minus 2 and x plus 1 if you solve by factoring. So that means your solutions are going to be 2 and -1. So my x-intercepts are going to be 2 here and -1 here. So then if I draw my curve, I know for sure that that's the solution. So one of the solutions is going to be 2, 0. Now my other solution is going to be up here somewhere. And if I had drawn my line a little better, it would have went this way. And if I draw my parabola out, I think it looks like they're going to cross right here. So that's going to be the point -2, 4. And I want you to notice that when you solve by graphing, that's going to be very imprecise unless you graph it on a graphing calculator. So that's going to lead me to the next method of solving a system of equations. But before we start the next system method of solving a system of equations, I want you to solve these by graphing. So you're going to graph your linear equations first, and then you're going to graph your quadratics. You can find the vertex and then find your x-intercepts by solving it, and then graph them, and then tell me where the line and the quadratic overlap. And those are your solutions. And I will give you the solution. So pause the video, do the 2 problems, and I'll give you the solutions after this. All right, so on the first one, they cross in 2 spots, and that was -2, 9 and 1, 3. And on the second one, they don't cross at all, but you do need to show me the graph where they don't cross or you won't get credit. And the answer is going to be no solution. I'm not kidding. I will not give you credit if you do not show your work. All right, so the next method of solving a system of equations is going to be with elimination. And so we have all this word problem here. They want to know what day was the attendance the same at both pools. So they want to know when did they equal. Well, we're going to take them and we're going to set them equal. And then they want to know what was the attendance on that day. So they're asking you X for the number of days. So when you find your X, that's going to be your answer to the first question. And then they're asking you Y for attendance, and when you find your Y point for your solution, that's going to be your answer to the second question. But we're going to set them equal to solve because they both equal Y. So if they both equal Y, that means 28x plus 4 should also equal -x squared plus 39x plus 64. So if we move everything to the left and solve for 0, we get +x squared. And 28x minus 39 is going to be -11x. 4 minus 64 is going to be minus 60. So if we factor that, we're going to get x, and we're going to get minus 15 and plus 4. So if I need to use a zero product property to solve this, I get that x can be +15 or -4. But because the pool can't be open for a negative amount of days, I can throw away that second answer because it's not going to work. So we know right now that it's going to be 15 days. And now we have to figure out how many people were there on that day. So if you'll just take 15 and plug it back in for x, you're going to get 28 times 15 plus 4, and that's going to give you 424. So your answer is going to be 424 people. All right. What we're going to do now is substitute, and it's pretty much what I just did. I didn't actually use elimination on the last slide. I did use substitution because substitution worked the best. And you always have to do what works the best. So for this one, you see how they both equal y? Well, we're going to substitute this in for this y. So we're going to set them equal to one another. I get x squared minus 6x plus 10. Equals 4 minus x. So if I move everything to the left-hand side, I get x squared. If I add x, I get minus 5x. If I subtract 4, I get 6. Now if I factor, I get, let's do minus 6 and, nope, not 6. I'm going to go minus 3 and minus 2. So my x's are going to be 3, and they could also be 2. Now I just have to find my y's. So what you're going to do is you're going to take your x and you're going to plug it in. What's 4 minus 3? It's 1. So when x is 3, y is 1. And then take the 2 and plug it in. What's 4 minus 2? It's 2. So when x is 2, y is 2. And that's your answer. Alright, forgot it. Number 3, I need you to pause the video and use substitution to do substitution on this one, I want you to add the 30 first. So you get y equals 12x plus 30. And now set this equal to this. And then when you get done, you can start the video back up and I'll show you the right answer. So here's your right answer, -6, -42, and 7 and 114. You have to show your work to get credit. If you have any questions, you know how to contact me. Otherwise, I will see you tomorrow in class.